Okay, today we're going to go through the wave function questions, okay, on the quiz. So the first one, it asks you to write 7 sine x minus 1 cos x in k sine x minus alpha form, okay? And then second bit is use that. So first thing what we do is we take that thing there and we expand it. Okay, so k sine x minus alpha is equal to k, remember, sine x cos alpha minus cos x sine alpha if we expand that one using our addition formula. Rearrange it so you've got the constant at the front. You've got k cos alpha sine x minus k sine alpha cos x. Remember, we want the x bit at the end. We then compare that to what we had up here, which is 7 sine x minus 1 cos x. And from that you can see, look, k cos alpha has to be 7 because that's got to be the same as that. And k sine alpha must be 1 because look, minus 1 is the same as minus that. So k sine alpha is equal to 1. Okay, so we've got our two bits there. For expanding it properly, I gave you a mark, and for getting to this stage, I gave you a mark. Okay, next bit, remember k is always just these two squared and added. So root 7 squared plus 1 squared gives me root of 50, which your calculator will neaten it up for you anyway, to 5 root 2. Get a mark for doing that. 1 mark for that bit. Okay, we now need to work out the angle. So remember, tan alpha is equal to k sine alpha over k cos alpha, which in this case is 1 over 7. Everything's positive, isn't it? So you're talking about first quadrant. Remember with your cast diagram, sine is positive there and there. Cosine is positive there and there. They're both true first quadrant. So here, all we really want is alpha will be a first quadrant one, so it's just inverse tan of 1/7. And if I work that out, that's 8.1 degrees. So, I think I give you 1 mark for that and 1 mark for getting the angle. Okay, the next bit of the question wanted us to find maximum, minimum and zeros. Okay, well remember what our thing looks like now. It's going to be 5 root 2 sine x minus 8.1 degrees. Okay, you also remember sine graph looks like that. So, if we're talking about the max would be there, wouldn't it? Now, its amplitude is 5 root 2, isn't it? So its maximum is 5 root 2 when this thing matches with that, which is 90 degrees, yes? So that gives you x equals 98.1 degrees. So you've got a maximum of 98.1, 5 root 2. That's the maximum. Similarly, we know the minimum is down here. Well, it's going to be, the minimum is going to be minus 5 root 2, isn't it? Because that's the amplitude, so it's minus 5 root 2. When this thing is equal to that, which is 270 degrees, isn't it? So that gives you x equals 278.1 degrees. So your minimum is 278.1 minus 5 root 2. I needed a bigger board really, didn't I? But it fits on anyway. Okay, the last bit I'm going to take a bit more space from because we wanted the zeros. Now our zeros are there, there, and there, aren't they? So the zeros. I don't need to write the zeros are 0 because that's the definition of 0. But it's when x minus 8.1 equals either 0, 180, or 360. If we work that out, that gives me x equals 8.1, 188.1, these are degrees, or 368.1. Problem with the last one, it's too big, because if you remember at the start, we wanted, we were up, well, in this one, we were asked between 0 and 360. I should have put that on here. We were asked, I think, for it between 0 and 360. So that one's too big, we can forget about that one. So those are our two zeros. So our zeros will be 8.10 and 188.10. So that's our maximum, minimum zeros. Now, where did I give you marks for this? I think I gave you 1 for that, 1 for that, and 1 for finding the zeros. Okay, next one. If we have a look at this, again, we've been asked to write that in this form. So expand this thing first of all. I'm not going to write it in green, that's a rubbish colour. Doesn't show up very well. Okay, if we have a look at this one, if we expand k sine x, remember k sine x cos alpha minus cos x sine alpha. Rearrange it so you've got the constant bit at the front, the alpha bit at the front. So let's compare it. This thing was 12 sine x minus 16 cos x. So again, if we're looking at it, we've got that equals that, and that equals that. So here we have k cos alpha equals 12, k sine alpha equals 16, because it's minus equals minus. So k, root of these two squared and added. You might have spotted it's a multiple of a 3, 4, 5. It's 4 times it, so it's 20. Or you could work it out. Okay, you've got tan alpha, k sine alpha over k cos alpha, which is 16 over 12. Both bits are positive, so we're talking first quadrant again. Yeah? Sine positive in those two, cos positive in those two, both positive, first quadrant. Okay, so again, this time alpha is simply going to be the first quadrant angle, which is inverse tan, well, 16 over 12 is 4 over 3, isn't it? And if I work that out, I get 53.1 degrees. Okay, so we found out all our bits now. Again, if you expanded that correctly, I gave you 1. If you compared it correctly, I gave you 1. If you worked out the angle and said it's a first quadrant one, I gave you 1. And I gave you 1 for working out k. Right, so that's where I've awarded the marks for this question. Second bit, I think they said hence or otherwise. If it says hence or otherwise, you do it as you've just done. So you should have written 20 sine x minus 53.1 degrees, which is what you just worked out, equals 10. Okay, you get a mark just for doing that, for doing effectively what they told you to do. Right, so we've got sine x minus 53.1 equals 10 divided by 20 is a half, isn't it? Should ring a few bells. Yeah, remember, exact values, it's going to be 30 degrees, isn't it? But we wanted answers between 0 and 360. Okay, remember it's sine positive, yeah? So we're looking at those two. So we're either going to have 30 degrees or 180 minus 30, which is 150. Remember I said exact values, inverse sine of a half is 30. So you can have x minus 53.1 equals 30 or 150. One for working out the first angle there, one for the second. So that's 2 marks. One for that, one for getting the second quadrant one right. Then you simply had to add on 53.1. So it gives you 83.1 degrees or 230. Yeah, that's right. 233.1 degrees. Okay, and 1 mark for doing that. Okay, so altogether this one out of 9. Most of the marks are for sticking it in this form. Okay, last question looks a bit different, but we don't need to worry about that in the first part. It's exactly the same as the other ones. Expand this thing, compare it to that, and we'll find out what alpha and k are. Right, this time, if I expand it, I've got k. Now remember, cos, a plus b will be cos 2x cos alpha minus sine 2x sine alpha. Okay, bring in the constants to the front. You've got k cos alpha cos 2x minus k sine alpha sine 2x, and you're comparing it to this thing, so root 6 cos 2x minus 3 sine 2x. So again, you can see k cos alpha is root 6, and use a different colour. Minus k sine alpha is minus 3. So that gives us k cos alpha equals root 6, k sine alpha equals 3. So what we have next is k is just those two squared and added, yeah? Root 6 squared plus 3 squared. 9 plus 6 is 15, so that's root 15. Okay, tan alpha, k sine alpha over k cos alpha, which is 3 over root 6. Okay, so, and again, everything's positive, so we're talking about first quadrant. Most questions deal in the first quadrant. Not all of them, but most. So if you looked at that, means both positive, so sine is top 2, cos is right 2, so it's got to be top right, which is first quadrant. So all we want is alpha is inverse tan of 3 over root 6, which gives you 50.8 degrees. Okay, that's the first bit done. So we got, again, 1 mark for expanding that, 1 mark for correctly comparing, 1 mark for working out k, and 2 marks for the angle, 1 for getting 50 and showing its first quadrant. Okay. Right, B. I think, did they say hence or otherwise? I can't remember. But anyway, whichever way, you use that. So we've got root 15 cos 2x plus 50.8 is equal to 1. So cos 2x plus 50.8 is equal to 1 over 15, root 15. Yeah, okay, so We're going to work out what the angle is first, so we're going to do inverse cos. Remember, we're going to solve it for the bracket first and then take it further. So we're going to do inverse cos of 1 over root 15 gives me 75 degrees. Okay, but because cos is positive, we know we've either got the first quadrant angle, which is 75, or 360 minus 75, which will give you 285. So we know that bracket, we know that bracket, which is 2x plus 50.8 is equal to 75 or 285. Yeah? So if we take 50.8 away, no, hold on. Hold on. Yeah, if we take 50.8 away, we're going to get 2x equals 24.2 or 234.2 divide by 2, you're going to get 12.1 or 117.1 degrees. But that isn't quite the story, because remember they said they wanted that. Okay, and remember our period for this thing is 360 over n, and n is 2, because it's 2 there. So the period for this thing is 180 degrees. So I can add 180 degrees to both of these, can't I? Which is one period. And if I do that, I'll get 2 more answers. So there aren't 2 answers, there are 4 answers to this thing. But you need to bear in mind the period of this thing is 180. So once we found our 2 sort of unique solutions, we could then add and subtract a period to that as much as we like to stay within the specified region, which in this case is 0 to 360. So here, 180, we can add 180 to that. That gives us 192.1. Or 180 to that gives us 297.1. Both of these are under 360, aren't they? I couldn't do it again because it'd take me over 360. But that gives us our 4 answers. Now, this second bit, I gave you 1 mark for the 75, 1 mark for the 285, 1 mark for getting to that point, and 1 mark, okay, 1, 2, oh yeah, I give you 1 mark up there as well. Simply for doing, when they say hence, for writing down the equation, you got 1 mark. Okay, and that gave you 5 marks for that bit as well, giving you a grand total of 10 for the third question. So the whole thing was out of 27 this week.